In this problem, we are asked to evaluate the limit as x goes to 0 plus of the function sine of x to the power 6x square. First, we notice that the limit as x goes to 0 plus of 6x square is 0. Moreover, the limit as x goes to 0 plus of sine of x is 0. In order to resolve this indeterminate form, we define the function y as follows: we set y equal to sine of x to the power 6x square. We will study the limit of logarithm of y. The logarithm of y is equal to 6x squared times logarithm of sine of x. The limit as x goes to 0 plus of the logarithm of y is equal to the limit as x goes to 0 plus of 6x squared times logarithm of sine of x, which equal to 0 times negative infinity. This is still an indeterminate form. We will use the L'Hospital rule to solve this issue. In order to apply L'Hospital rule, we first have to rewrite logarithm of y as a quotient. And then, take the limit as x goes to 0 plus of the derivative of the numerator as well as the derivative of the denominator. The derivative of the numerator logarithm of sine of x is the fraction cosine of x over sine of x, and the derivative of the denominator, 1 over 6x squared, is minus 1 over 3 over x cubed. We simplify the numerator of logarithm of y as x cubed times cosine of x and the denominator as minus 1 over 3 times sine of x, and take their limit as x goes to 0 plus. We see that both limits are still 0. Therefore, we still have to repeat the process one more time. The derivative of x cubed times cosine of x is minus x cubed times sine of x, plus 3x squared times cosine of x, and the derivative of minus 1 over 3 times sine of x is minus 1 over 3 times cosine of x. When we take the limit as x goes to 0 plus of minus x cubed times sine of x, plus 3x squared times cosine of x, the result is 0. And the limit as x goes to 0 plus of minus 1 over 3 times cosine of x is minus 1 over 3. In sum, the limit as x goes to 0 plus of logarithm of y is 0. Eventually, the limit as x goes to 0 plus of sine of x to the power 6x squared is equal to the limit as x goes to 0 plus of exponential of logarithm of y, which is equal to 1.